Hello, welcome back to this small tutorial of finding your way around Rhino. Here I'm going to be showing you most of the tools, both located here, as well as how they change whenever you change your tabs. And then these panels over to the right, where they interact with a lot of the tools, but are also just generally useful panels for things like layers, display settings, sun settings, those types of things. So in order to start talking about the tools, we're going to have to talk a little bit about how Rhino makes and classifies geometry. So most modelers, or at least traditionally most modelers, have been polygonal in nature. So they will make a shape out of many or as few triangles as possible, depending on how you've defined your shape, in order to approximate a 3D form. Rhino doesn't do this as its default. It can. So meshes are what those things are, and there's a whole set of mesh tools up here. But generally, what we're using are vectors and NURBs and other mathematically defined surfaces. So if I select this object, you'll see that it has, 6 sides, as well as, and we'll turn Gumball off here just because it's a little bit easier to see for a second. It has these lines coming through the middle when I select it, that are defining the surfaces mathematically. But generally pretty flat. This would be pretty easy to represent with polygons, but you would probably see a triangle coming around the diagonal here. Things like this line, it's just defined by 2 points. Lines are almost always straight, so all you need is 2 points in order to get that data. That's something important to remember once you start getting to Grasshopper. But there's a lot of different types of objects that we generally will just refer to as lines or curves. So overall, curves, and this is where curve tools comes from, are anything that are like this line where they have no thickness, they've not been extruded in any way. They're just essentially like a path for things to follow. This is similar to the splines and Bezier splines that you'll use in Photoshop if you've ever used the pen tool, and in Illustrator. Really, the geometry underneath this are called NURBs. It is a very technical term. In fact, if we go to Rhino's website, they have a whole article on this. I encourage you to read through this up to the point where it sounds like gibberish, because there's a lot. It is important to start knowing and understanding how knots and control points work, what the different degrees generally are, but it's rare that I encounter them when dealing with architecture. And if I do, it's usually more in a, does this look quite right, or does this look quite right? If you're really dealing with some of this advanced geometry, you're probably going to start doing physics modeling. And at that point in time, those factors are controlled by something else. You can kind of see an article on Wikipedia that explains this a little bit better, as far as just kind of how you can define these points, but overall you'll get this curve. There are a bunch of different ways to look at these. There's a bunch that have been developed, T-splines also exist. I believe Autodesk has a patent on those, so they're not in Rhino anymore. But you can kind of start seeing how this defines polygons. This is a much newer way of defining these types of surfaces. Rhino does this. SolidWorks generally does this. This is the advanced version from polygonal modeling. This is important to know just because as we start talking about doing things in Grasshopper, or how some of these tools interact, knowing that it's not just triangles and shapes like what SketchUp would use gives you more power, and it also allows things to be more flexible, but it also makes it hard for certain tools to talk to other tools. So we're going to just stick on a couple of these and go through them fairly quickly. I encourage you to come through and start looking at a lot of these. Some of them are pretty niche and you won't use, like the polygon tool. You won't always need a pentagon or a hexagon for certain things. You may just draw that manually once or twice and then copy it, or use something that's slightly off. But generally, lines are the simplest. They're just 2 points that you define. You can find them up on polyline here. There's a little drop down menu, just clicking on single line. Whenever you do that, notice up here that it has this like underscore line. It's essentially the same thing as if we just typed in line and hit enter. This is why I use the command line, because going through these takes a while, but typing things in comes a little bit faster. What this normal one here is polyline. So if you click on it, it's going to ask you for the start, and then the next point, and then the next point, and the next point, until you get done. You can either hit enter to get done, or you can come and close your polyline, and it will automatically close it, since polylines can't really be tree-like. There are control point curves. So this is one of those NURBs where you can kind of just click several like points like this. You'll notice it's a line right now, but as soon as I start moving upwards, it's like attracted to that second point, but it's not staying there. Same with that last point, same with that point, etc. So, and if you click on this curve, you can see this same shape show up. So this is literally what they're getting for their Wikipedia diagram of this. It's literally the same thing. You can kind of see how things kind of hit towards the middle here and intersect when it inflects, or it doesn't touch all the way. Generally, this can be a free-form way of doing this. I often find the control point curve, where you manually define the control points this way, not as useful. I use the interpret curve whenever I'm inside Rhino. So if I click on this arrow here, you'll see this one, which interpolate curve, my mistake, where you have these 4 points, but they're not outside of the curve, they're on the curve. This forces it to be on that point. You'll notice it can kind of get wonky as you get closer to it. But generally, if you're tracing something like a contour, this is easier. You just have to drop more points occasionally. Now, these control points are defined by, or these curves are defined by control points, and you can modify them, and we will definitely be doing that in Grasshopper. But for now, just get used to drawing and messing with them. Other things that we have are like rectangles, where, you know, we can start with one corner and go to the other. We can also do a rectangle, and you'll notice that there are like these options up here. A lot of these are clickable. So I almost always use 3 point whenever I make a rectangle. Essentially what I'm doing is I am defining how wide and then how long the rectangle is. So if I click that, when I start now, I'm not making a rectangle, I'm making a line. If I want to make it orthogonal, I can hold shift. And if I want to keep it orthogonal, but I want to like start typing something else, I can hit the tab button. And from here, I can like type in how much I want it. So there's a little cursor up here at the top, and it's essentially asking you for a distance or wherever that end is. So if I say I want 25, so 25 inches, I just type that in, and you'll notice that no matter what I do here, this point stays the same. Hit enter, and then say I want this, 10 the other direction. I can just type in 10. Because it knows a rectangle is going to be perpendicular, it knows it's going in that direction. Just be aware that if you flip over here, it's going 10 this way. And if you go on this other side, it's 10 this way. So that's a pretty simple way to make a shape like that. You should experiment with some of the circle tools and the ellipse tools if you plan to use them. These are just the standard tool set, so it's kind of got a mix mash of all of them. If I go to curve tools, this expands out a little bit more. There are a lot of ways to find a circle. There are a lot of ways to define curves, or even specific curves like parabolas or helixes. So those can be really useful if you're making your own screws, for instance, but they're going to be pretty niche. You'll notice up here, whenever I went to curve tools, this whole set of items changed. That's going to be basically editing tools generally. They're kind of grouped into different things. You see this small line here and this line here, where I believe one of these is rebuild. Yeah, this is essentially changing how many control points there are and how evenly they are distributed. It can mess up your curves, or it can make them look a little bit less janky depending on how you've been drawing your curves. There are other things like adding symmetry, blending different arcs together so that you have tangents, so it's not just a sharp cut. Things like chamfering, which we could do on one of these. So if I chamfer this curve and this curve, you'll notice that it went ahead and made this diagonal here. You can do things like filleting and everything else like that too. Other things like projecting curves onto other things are really useful. Tweening between two curves. For an example, if you were doing an auditorium, we're just going to do a simple curve. Doesn't really matter. Hit enter to finish that. And we're going to do a bigger curve, but we're going to make it more bendy. So say I wanted seating in between here. I could come up to here to the tween. And it just wants me to select the start and then the end curve. And then it's going to ask me how many, it's going to ask me to accept these options. So there's things like, what layer do I want to put it on? Do I want to flip things? Do I want, a certain number? Play with each of these to understand what these different commands do. But I'm just going to go for a number right now. Say I want like 5 curves in between. You'll notice that I just hit the 5 and those 5 pop up. We're going to hit enter to accept. And so now we have what are essentially evenly distributed stuff. Really, really nice tool if you're having to like manually rebuild or draw lines for contours because something isn't showing up quite right. Or if you just need something to start creating some sort of pattern or geometry, you can kind of start doing it here without having to like open up Grasshopper or manually draw each of these or scan something in. So moving on from curves, I'm going to go ahead and delete this because it's starting to look really messy to me. We're going to look at surface tools. So surfaces were whenever we expanded one of those curves. So they had an area component to them. Curves have no area, they're just lines. But surfaces, by definition, will have areas. So you can do a variety of things. So I'm going to just drop a couple of points like that. By the way, if you hit spacebar or right click, it will repeat your last command. So these are 4 points and they're all on this plane. We can go ahead and create a surface from here, from these 3 or 4 points. Just like that. And it was just this surface from 3 or 4 corner points. Or surf point is your command to create those. And it's basically a surface. You'll notice it still has these 2 lines in the middle. What are our U and our V for our surface? That's important for later, but not for right now. If you want to make something that isn't necessarily flat, flat's pretty easy to make. We're going to turn the gumball back on. If I move this up, and I guess I'll move this one up too a little bit. So now they're kind of in a weird organization. You can do the same thing. And I'm just going around in a circle here, essentially, between the points. And you'll notice we've got like a surface, like a shell that goes in between them. Kind of like a nervy, like concrete shell. The order that you select the points for this really matters. So this turned out well. Our U and V are going this way. It's a full shape. If I do the same thing, but I zigzag my way through the points, you'll notice this hourglass start to form. Now, this is still a valid surface, and this might be your desired outcome here, but it is drastically different. So this kind of just tells it like how to draw the outside border, and then these UV curves kind of like interpolate things in the middle. So be careful whenever you're using that type of tool. The order that you select things matters. There's surface from 2 or 3 edge curves. So if I just drew a couple lines and the curve, we'll go for a piano shape like this. We can look at this surface from 2 or 3 or 4 open curves. We'll hit enter and we'll make that surface. We can also move some of these things around. I'm actually going to use the move tool to make sure that those touch, and then do the same thing. And it will make that also. It limits at around 4. It starts to break after that point in time. There are other ways to do that, things like the patch command here, but try and limit yourself a little bit in the beginning before you start using that. The patch tool is a hotfix type tool that I use to make things solid and not necessarily to make them good. You'll notice that things like rectangular and rectangular planes are here. So rectangles are just the lines, but rectangular planes are full surfaces. You can go from a rectangle into a surface, so it's not a surface right now, by doing something called it is surface points. No. See, the command line's great until you forget a command for it. SRF tends to be the prefix for surface almost all the time. Planar surf. Okay. Finally came back to me. Planar surf. So planar surf only works on planar curves. So if you have things like how we had that curve on the outside of this thing, how it was not planar anymore, it does not work. But because this rectangle is planar, it will. It will obviously break on some circumstances. It's easier for me often to remember rectangle, and then, even though I forgot it just now, planar surf. But you can also just use the plane command, which I forget about very frequently. There are a handful of other variations here. You'll also see that there's like extrude. So if I click that, it just wants me to select some curves. In this case, we'll do this rectangle to extrude. And then it's going to ask me what type of distance I want. You'll also notice up here that there's a couple of options. Both sides would be to extrude on both sides of it. There's solid, which would be to make it a box. This is similar to the push and pull command in SketchUp. Whether to delete the original input, so that would get rid of that first rectangle, which you may want to do. And then a couple of other ones. So planar surf and extrude surf are good ones to remember. There are a couple of others, so we'll do a curve. If you're familiar with the geometry building in Revit, then a couple of other types of geometry creation exist too. So like in Revit, you're going to have things like extrusions, but you're going to have sweeps and blends. They have slightly different names in certain circumstances here. There's like actually multiple types of sweeps. And then there's also, in this case, blend, which is loft. If you type in the word loft, it's going to say which curves do you want to loft, this one and this one. I'm going to hit enter. It's looking for a seam point, so this has to deal with which direction the curves go. So I drew them in opposite directions, it looks like. In that this is going left and this is going right. This will give you a weird hourglass shape if we do it this way. You have to click on the arrow to get it to go the right direction. But now these are both going the right direction. If I hit enter, it's going to give you a couple of options here. Feel free to play around with those, but you'll see it's transformed the bottom thing to this thing. It's often doing this with mostly straight components. If you make a third one, and this is something that Revit has a very hard time doing, and then loft them. So now I look at this, and the seam here, these look fine. Now this one's going the other way. I guess I have a preference for drawing them certain ways, certain times. But anyway, we have all three of these. You can see this line that goes in between them showing the order that we're going to, and then how we've adjusted our seams. And you'll see it's kind of making a more blobby shape. It's less straight lines. You can make it all straight sections still by doing one of these. They are, see, this one doesn't quite touch all of them. Your mileage is going to vary with which one of these are going to be useful if you use this tool a lot. But this is a good way to get a pretty funky shape pretty quickly. You'll notice that it has all these extra lines. They are similar to the extra UV lines, which actually are not showing up on this base extrusion. They are still U and V lines, but it's just how this has defined itself. There's no easy way to explain this outside of the fact that it has to do with the distance and the amount of control points each of these curves have and how they interact with each other. It's one thing that starts to get more important if you do this type of organic modeling a lot more, or if you start using stuff in different lists and need to build from the same amount of control points. We'll eventually get there, but for right now, don't worry about it. Keep one of these. So then there are sweeps. So some of these tools are down here. So sweep 1 rail, sweep 2 rails, revolve. Don't use drape that much. Loft is not down here. This is where planar surface was the whole time. We'll do a sweep. So in a sweep, what you're often doing is creating something that goes along a rail. So if you think of baseboard molding, where you would have something that looks, something that might be, and I'm just kind of, ignore the scale of this. It's like huge. It's like an 6-inch tall baseboard. So say you had something there that had a simple just notch out of the middle of it, and you wanted this to follow around something. First, I'm going to join these because they're all separate right now. And then I'm going to stand it up on its side. Okay. So if I had a line that I wanted this to follow, so say this line, I could do sweep. It's going to ask me to select the rail. That's going to be this one first. And then select the rail, and it will automatically move to cross-section curves. So this one, and hit enter. This is once again asking about the seam point. We're just going to hit enter, and we're going to say OK. And it has made that object. It hasn't given anything on the edge, but it's made that object. If we do this again, and then if we make this a surface instead of a polyline, and then sweep it with the rail and the surface edge. Oop, it's only pulled one edge. There's a way to do it where that closes automatically. Oftentimes I just use a command called cap, but it's not that important. It's useful for generating some geometry, but this is really detail-y. If we wanted to, say, make something that was more or less going around something curvy, same thing. We just select this as our rail instead, and we select this as our cross-section curve. And then we've got it. This would be like if you took your router, like a trim router, and you followed the edge profile exactly, essentially. So that's sweeping and lofting. There's another sweep too where you actually use more stuff, and there's revolving, but feel free to explore some of those. Finally, I guess not finally. We're going to talk about solid tools for a little bit. Solid tools are not the most useful initially, just because you're often going to be looking for solids that are not these primitives. But we'll create a couple here. In this case, box is probably the one you'll use the most. Once again, I use 3-point because I want to define the width, the length, and the height. I'm going to right click. And you'll notice that when I right clicked, it did not go back to 3-point. Doesn't matter right now, but we've made 2 solids here. Generally, we try to avoid this type of situation. It's okay when you're like sketching things, but as final geometry, it's just kind of weird whenever your stuff clips together like this. Like this is fine, but as soon as we start moving this thing into this thing, you lose some of those lines and those drawings that you'd normally expect even out of a normal architecture drawing. But if you do have intersecting or overlapping boxes or other objects, we can do an ellipsoid. Then you can do some Boolean transformations on this. Be aware that there's a limit to what you can do for Boolean transformations, but ideally, the objects you pull out of Boolean transformations are ideal for things like 3D printing where they're totally watertight and solid. So those tools are up here at the top. Boolean union is this one. That's basically going to add one or 2 or more of these together. So if I hit enter to that, I've just added those together. Now it's all one big thing. You'll notice even that there is a line that kind of happens in the top. We'll actually move into ghosted to see this. In between the two, just like you would want on a good 3D model for 3D printing. Go back to shaded. There is Boolean difference. So if I wanted to take out this shape from this shape, I would, and it's telling me which polysurface to subtract from. So this one, and what to subtract, I hit enter, and then what to subtract with, this one. And then normally when you do this, it will delete the one you're subtracting with. I actually have it set up to not delete that right now. That's just an option up there that you can hit, which we will just go ahead and do this again. So subtract this with this. See, it says delete input no. If I hit yes, there it goes. So once again, very primitive way to start messing with these things. It makes more sense to me to think of the solids as like clay that you have to sculpt away in this way. But however you decide to use it, it's going to be up to you. Finally, there's going to be like an intersection where you can take, this and as the first set, and then this is the second set, and it only gives you what is in between, which is kind of an interesting shape. And then this other one, which is split, which is if you have something that you want to cut apart, you can use this to cut it. This is not going to, this is the thing that did the cutting, but this is the thing that got cut off. So once again, it can be useful in design thinking. It's really hard to continue using this type of formal analysis for a very long time because it will start to break eventually as you start adding more polysurfaces and have coplanar things. But just be aware that that's there. There are things like solid control points also. This is closer to like the points that you might edit in SketchUp. You can do things also like adding holes, in this case a round hole, which I'm going to basically just place onto here. And in this case, it has a certain depth and stuff. And these are more for if you're talking about machining something. Using these types of tools are much better to use. Things like shells also exist. So like if I wanted to remove, these faces from this surface, and then it gave a thickness of 1. It's telling me that there was an error in doing that, but you've seen it's trying to give everything here a wall. It would be easier on something like this. We're going to go with thickness of 0.5. Get rid of that wall. So now you have like a shell of that, which can be really useful for certain types of modeling. But feel free to play around with some of these as well. Is there anything up here that I needed to talk about? There's a handful of things to fix, but I honestly don't use the surface fix tools that often. The final thing that we're going to talk about as far as like creating stuff is mesh tools. I would recommend avoiding using these as much as possible. We will use them a little bit in Grasshopper because in some ways they're simpler data to have to mess with in some circumstances, but generally you get a lot of the same things where create a single mesh face where it can be something like that, or where you have a box where it's made out of a grid of different faces. I kind of drew that one very thin. But there are a lot of issues with using this in that it doesn't interact with the NURBS very well. These are mathematically defined completely differently. And so getting them to talk gets really difficult. Generally, you're going to want to stay in this world until you are ready to move into that world, which you will use for fabrication or for some rendering purposes, but not very frequently. Go and play with them, but don't get too hung up on them. You can spend forever trying to fix meshes whenever it's faster to just rebuild something as a surface. And that's a really unfortunate thing that I sometimes have to do for 3D printed objects, but hopefully I don't have to do that often. Get rid of these meshes. The other things that I want to show, and we're going to try to go quickly through this, are the selection tools. So this is giving you the standard tool set on the left, but you have all these selection tools up here where you can select just theoretically all the points. So it's pulled all of those individual points, so I can do anything I want to with them as a unit. This can be really useful in Grasshopper because you may only be dealing with a small subset of information, but you may only want point data or line data. You can select the last created object, which was this one. That's sometimes useful if you get lost or forget what you were doing. Things like if you have hatches, select all of them, or select all block instances. That depends on how you're building your model. And you can invert your selection as well. So everything except for that, which can be useful, especially when you're deleting things. All of those types of tools can be found by typing SEL, and then you will get a list of way more things, like anything that's circular, anything that's closed curve, anything that's closed mesh, or a poly surface. They all will show up. This is a really good thing to just know about. As you start needing to sort through some of your geometry, this is going to help you do that much faster in a lot of different ways. Another tool is if you only want to work on this and you don't want to delete other things, you can hide them. So just type in hide, and it's gone for now. Like I can't select or do anything with it. I can do that to this one too. If I want to see them again, I'm going to type in the command show. This is okay if you're like working on stuff for a little bit, though I would caution you to keep things in layers that you can turn on and off like you do in Photoshop. But you can also do the opposite, where if I only want to see one thing that I'm working on, so say I have like walls around this and it's getting hard to like sculpt this because I keep like ending up behind them, you can do something called isolate. So all the other geometry still exists, but this is the only one that I see right now. If I type in show, it will pop back up. That's a really useful tool. Finally, the other thing I want to show you are... It's not the final thing I want to show you. I'm going to show you how to set your view. This is useful if you zoom out really far or if you notice you're rotating around something that isn't quite right. So we're going to... I was trying to get my... There. Okay. So you'll notice that I'm rotating around something in like the vacuum of wherever this is. It's nowhere near where I'm at over there, so it's kind of hard to keep that into the right view. There's a couple things you can do here. One is, so say you're like totally like off and you have no idea where anything is. There are a couple of tools like zoom extend. So this does basically whatever viewport you're in, zooms everything into view in the same direction that you're looking at it. It will generally not change direction. You'll notice now that it's kind of rotating around the center of the group of objects. If you have something selected, but you are not currently in view of it or you're not rotating around it, you can use zoom selected and it will fill it up on your screen as much as possible. It will also center your view around that same point that the gumball's at. If you have a specific thing that you're trying to like really hone in on, you can use this zoom window where you just draw a little window around it and we'll kind of focus in on that. This is more useful in perspective. You don't have to worry about this so much whenever you have a top or a side view, but it is an option. You can also basically change your view to be oriented to something. So this would be like the bottom view of the Z plane. This would be the top view of the C plane. So it's everything from directly up above. Once you rotate it, it's no longer that, but things like if you're looking for elevations, etc., or the bottom for some reason. These are ways to go ahead and do that. There's a couple of like perspective matches if you're trying to match an image to a certain projection or a image or something. Once again, go ahead and play with those. The last thing I want to explain are C-planes. I don't expect you guys to change these very often, but the C-plane is essentially this. These exist in Rhino whenever you're building geometry. Whenever you get really heavy into like that, you're doing a lot of the same things, but generally you can change where your origin is. So that's going to be this thing, and you can see it changing right now. This changes essentially the numbers of everything in relation to the C-plane. Be careful with this. Depending on how you've defined certain things, you could, start changing whether something's a positive or a negative number. Or if your function has something that's relying on that, that could potentially be an issue. There's a lot of ways to reset your C-plane. They'll generally be around your origin. So this would be C-plane from the world top, and it uses the world axis, which is the 0, 0, 0, like the master 0, 0, 0. But if you change what your world origin is, it'll go around that. You can do it from the side, and this will look super trippy. Actually, what did I do this for? I did that from the view, so we're going to set that back to where it was. We are going to do this from the world front. There we go. So you'll notice that this is now up and down. Whenever I try to draw a polyline, I'm now drawing on this. So it trips me out a little bit whenever I change this, but in some circumstances, working in elevation is much more useful, like when you do furniture profiles. Same thing if you go from the right or the other side. Just know that you can reset stuff here. You can also like do much more custom things where like your Z axis is slightly off. I wouldn't recommend doing that often, but if you, for some reason, mess up your C-plane, this is the button to remember. C-plane to world top. So that's probably the last thing I want to cover in this video. This one was a bit longer. We're coming up right on 40 minutes. There's a lot of tools here. Just parse through this when you can. The more you use these tools, the more familiar you're going to get with them. It is going to take you a while to like get proficient to do things quickly. Eventually you'll get a flow. I find this flow nicer than the 2-button shortcuts in Revit, especially considering how Revit moves and changes things. But it's also has the option to be a lot messier at the end. I don't have to worry about levels here, but I also don't have anything that can correct things onto levels. So, and it doesn't auto-generate stuff. You basically have to make everything. It's really useful if you're doing something very custom, but it can be frustrating when thinking about it from a construction document standpoint, where you would naturally have a wall thickness. None of the stuff I've made besides this shell here has a thickness that isn't just like the whole thing solid. So there's a lot of differences between this and Revit. It's going to take you time to get used to it. We're going to mostly be in Grasshopper, but hopefully this gives you some sort of trajectory to look at stuff. Thanks.